Hello everyone. In today's stream, we're going to be continuing our port of the package resolved game to the Playdate and continuing our prototype. As we had left off prior, we were just wrapping up basic movement and we were starting to look into image rendering. Today we'll hopefully be continuing that and focusing on getting a sprite sheet up and running. Okay, let's see. What's everyone up to here? Oh, it's just me right now. Ah! Okay, well that'll be fun. Well then in that case, I'll just keep going. Can I hide that? Let me hide that. Okay, that was weird. Right, so I have done some behind the scenes things, just to give the project a little bit more robustness. So if I were to switch over to that real quick. So we're back here in our make file. You'll notice that I've made a couple of changes. Grabbing like the C compiler for one. And I have added support for unit tests in here because I want to make sure that whatever we're writing that can be made like a common utility. I want to make sure that that we are having that thoroughly tested, just to make sure that we aren't getting a whole lot of bugs. This is something that I like to do on the iOS side of development as well. Focusing a lot on test-driven development. I think TDD may be a little bit difficult with this project, but we'll see how far we can take it. Since a lot of the stuff right now is just manual testing, hopefully we can write some unit tests to make that a little bit easier. Only concern would be when we would have to eventually add the Playdate SDK to the shared library that we've created. So if I were to run this, just to kind of show you what we're up against. Make test B, because I got to do this to, I guess, void the timestamp or whatever. So we've gotten it so that way the compiler now opens up and compiles the tests. And then I can just run our test app here. You can see that I've written some initial unit tests here for the translated movement and for just creating a vector, just to make sure that we're initializing that properly. Very basic stuff, but again, A, just to make sure that the test part is working, and B, that we actually are ensuring that we are writing these tests as necessary. Why is my desk wet? Desk is wet for some reason. So we have that. Also had to slightly modify the clean command just to also get rid of the test app once we're done there. And then likewise, I have also updated the README to just include those instructions now, so now it's a little bit more clear as to what we're doing. Prior to this, I had temporarily switched over to CMake. CMake is rough. I am not a huge fan of it. I prefer just the regular standard Make, because although Make has its quirks, it's a lot simpler to understand what's going on. So for the time being, we're going to be sticking to that. So I've removed all the older CMake stuff and had to re-enable the Make file in our gitignore just for that. Right, okay. And then one other setup thing that I had done prior to starting today, the sprites, because we're going to need a sprite sheet to work with, so I took the time to sit down, did this last night, take the sprites for the original game and just kind of recreate them a little bit. I may need to tweak the art because it looks kind of less like a bird right now. But yeah, you can see that this is what it looks like. And if I were to run the simulator, but before doing that, actually switching it over to show show our sprite sheet, you can see this is how it renders. I initially had this at 1 times, but it looked a little small. So I'm deciding to just have this scaled up 2 times. This part looks a little funky just because of the fact that it's against a clear background. I assume that that'll probably get changed whenever we eventually have a background and stuff moving around. So yeah, that's where the project is at currently. So I'll move this back to Splash. That does remind me. I am reaching out to the original sprite artist for the original artwork here, seeing if he can get this recreated for the Playdate's screen. Taking a little while to figure that out, but hoping that we can get that resolved so I don't have to resolve to these weird dithery looking ones, because I don't know how well this looks on an actual Playdate device, because in the simulator it looks a little funky. Probably not as bad if I were to like zoom this in 2 times, but like the smaller it gets, like the weirder it just kind of looks, and I'm thinking we can better optimize for the smaller display. So with that in mind, let's go back to here. Also, why is this open? Shoosh. Oh, what's up, Quantum Mechanics? See you in there. Just popping in. Yeah, so we just kind of briefly went over the changes that I had made since our last stream. Mostly just adding unit tests and getting some sprite images ready for us to play around with. So that way we're not sitting here for like half an hour as I'm like trying to draw these sprites out on stream. Sounds complex. The process of getting the unit tests up was very complex because it went through a whole bunch of things, but now unit tests are just really dead simple. It's just adding stuff to this file and then just running a thing to get the test running. For anyone wondering, I am using the micro unit test library. I initially had the entire source repository in here, but then things got a little bit difficult when trying to get that to run, so I just pulled out the actual CNH files and just dumped everything else. So with that in mind, let's revisit our tree here. So in progress is creating prototype. Come back, drawing sprites and images. So use a sprite sheet to draw animated images. Alrighty, that is where we were at. As I had shown just a couple moments ago, this is the current sprite sheet we have. 6 frames, and it's just a running animation. So let's see if we can figure out how to get that to work. Because right now, oh, that's the unit test. Let's close out the test folder. There we go. Alright, so we can get a static image to display just fine like this. Make the display bigger. Alright, we can get just a regular image as it is, but it's not animating, so let's see what we can do about that. So the first thing that I want to do, why am I hovering over there like as if the dock's there? Oh, okay, bye. Where were we? Right, okay, so let's take a look. Here, I don't know. Is there anything for sprites? New sprite, free sprite, set bounds, move to, move by. Okay, so that... Okay, that's interesting. Sprite set image. Get Z index, set draw mode, set image flip, set stencil. New sprite. So, okay. I see. Okay. So maybe let's start with creating a sprite then, just to see if we can at least get that to work. So we'll get rid of this line. Well, actually, no, not yet, because we're going to still need to do things. So we'll do that. Const.char /path. Right, so this is going to be our sprite table, or sprite sheet. Splash path, sprite sheet. Right, so we know that we have that available. And then I think we're going to need to, yeah, like that, just so we're up to date there. So I guess we're going to need to create a new sprite. So we'll do that. LCD sprite. Sprite is PD. What is it? Sprite, new sprite? New sprite. Okay. And then what we want to do next is we want to set the image here. Right? Okay, so then we're going to want to do sprite. Oh no, never mind. We don't do that. We do PD sprite set image. Okay. So we have an LCD sprite. Oh no, that's where we pass in our sprite. And then we're going to pass in the sprite image. Yep. And then LCD bitmap flip. Let's look for that. Right. That's our constant of the K bitmap on flipped. Okay. Excellent. Excellent. So let's come back real quick. Oh, I need to just jump back this way. Okay, so we have that. Do we have like a draw method somewhere? Get center set image. Set size. We may need to do that. Playdate sprite set size. Okay. PD sprite set size. Sprite. Okay. We're gonna need to open this back up and sprite real quick. Gotta load Steam before I can load sprite. Thanks. That's not what I wanted. Oh, gravy. Okay. Oh, here we go. What is your width and height, my guy? You are 32 width, 64 height. Okay, that makes sense. 32.0 F and 64.0 F. Right, because if we were to look back at this, yes. Okay. Get tags, set text, set draw mode, get image flip, set stencil, clear stencil. A lot of stuff. adds the given sprite to the display list. Okay, so we're going to need to do that as well. PD sprite add sprite. Oh, that's just it. Okay. So then... okay. So finally, at the end, we do PD sprite update and draw sprites. Okay. Let's see what that gets us. Oh, that's interesting. That is very interesting. So does that mean that we need to move this? I'm trying to remember what our method here for that is. It's like move to, I think, right? Move to? Yes. Move to sprite. I think that does the trick. Okay. Yeah, okay, that's something. That's something. So I think we know what we can do for that. Right, because we have our code to do all this movement stuff. Let's actually bring this back. And then we'll store the sprite here. Like that. So let's see, what do we need to do? If initialize text position X. Okay, so we're going to change text position to sprite position. Because that's what we're going to want, right? So the sprite position, text position Y won't ever change. So then what that means is we can change this to say, PD sprite move to, right? Because we know this is what we can do now. Then we can say sprite position dot x, and then sprite position dot y. Initialize game loop is true, return 1. Oh, you know what? We need to bring back our method to actually draw the image. And then I think we just need to take this, like that, and then we just say sprite position formatting on here is a little funny. Right, sprite position. This may or may not work. We're gonna find out. Build failed because local bin updated undefined reference to get translated movement. Even though we have movement defined right here. Oh, because I think we need to actually add it here as well. That'd be my guess. Vector.c. Ah! Now what happens if we... All the birds. All the birds. I mean, that kind of works. We may need to find a clear function, though, to clear some information. See, do we have a clear? We may need to make it dirty when we do that. Okay. Let's see if that helps. Move to. If I can spell for the life of me. Is that not what we do? Playdate Sprite. Make dirty. Sprite. Oh, it's mark dirty. Yeah, that makes a lot of sense. Okay, no, we're still getting infinite draw calls. We may need to just remove it and then re-add it. Maybe. Could try that. No, that's exhibiting the exact same behavior. Could also be this is just being called multiple times. What am I doing? Oh, you know what? I don't think the Playdate uses printf to do that. Don't we have like a console? Utility functions logging. Yeah, we want PD system, and what is it? Log to console? Let's see. Where do we get our console from the simulator? Oh, maybe. Come back. Thank you. It's probably that. Oh, yeah. Oh, yeah. That would be why. So I think we just need to change that, I think. If sprite image is not null, and sprite is null, okay, yeah, now that's working as expected. Print debugging. Okay, so that's very interesting. So, We got the movement more or less figured out, which is good. We're just not getting the frames to animate. And also, I think the 0 position is kind of throwing it off a little bit. We at least know the height of the thing to be 64, so I think we could just lower this to 32, and then that should... Yeah, so it's at least a little bit more visible, but I still would prefer she were a little bit more to the top. So we'll do 16 and see how that goes. 24. Feels like a very arbitrary amount here. Oh, this also lets me control the crank. Woo! Look at this spin. Okay, excellent. Well, it didn't take long for us to figure that part out. Great. So, I mean, we can more or less mark that done. So we can say, move a sprite according to crank. It's nice. Got a little ahead of the tree. So that's always a good sign. So now it's just the sprite sheet here that we need to worry about. So that's going to be interesting. Nothing in the chat so far, that's fine. Also, I just realized I forgot to move this back to the small again. Oops. At least I caught it. It's probably going to not look so great when you go back to watch this. But just to briefly show the code that we just wrote here, we just modified our original code to... we just modified the original code to now draw the regular sprite here and use the position that we calculate ahead of time to handle actually moving the sprite around. The only thing that we haven't done is getting the actual sprite to animate, because you can see it's still just the standard stock full image. We have frames. We want to use them. So let's figure that part out. So what's going on over here? Oh, just some stuff going on. Okay. So let's go back to this and see what we need to do. Bitmap tables. Return the index in the bitmap table. Returns a new file at the path. Load into bitmap table. So what is a bitmap table? Okay. Do we have any information that says what we can do with that? Get bitmap data. Load bitmap. Well, we already know how to load the bitmap. That's not an issue. Draws the bitmap at location X inside a width and height rectangle. Okay. So let's try that. Oh. How are we gonna do that with the sprite though? Okay, you know what? We're gonna play around. We're going to play around. So the method we want is tile bitmap. this may or may not be what we're looking for. So I'm just going to comment that. Let's see, PD, graphics, tile bitmap. Let's see, or no, we need to just pass the sprite. Image, int x, int y, so we're going to want to do 0 on both of those. 3264K bitmap unflipped. I just want to see what happens when we do that. Yeah, that doesn't do much for us. I think it's because we need to do something with the actual sprite, probably. Set size. Set stencil pattern, set clip rect. Sets the clipping rectangle for sprite drawing. Int left, right, top, bottom. Okay, so I guess let's make a rect. I think we should be able to do this, right? So left, 0, right would be 32, top 0, bottom 64, I think. I guess that's the LCD rect. I don't like when it jumps around. Okay, so let's do that. PD sprite set clip rect sprite get rect. I don't think this is going to do what I want it to do, but yeah, no. Because I think that's actually manipulating the display. So that's not what we want either. Okay. Set updates enabled. Set opaque, set always redrawn. Set update function. Collisions. Query info. Okay, so how does one do this? Playdate sprite sheet. Okay, I need to turn off this boost because it's interfering. Tools. Quick settings. Dark theme. Thank you. Okay, we're back. Inside Playdate image graphics. There are two kinds. Okay. Now, is this on the... For a tile map, for sequential frames... With the files, image table, new, frames. To load a sequential image defined... Oh, we're looking at an old version of the SDK. That's not going to help. Image table. To load a sequential image defined with the files, you can call So we need to split this? Is what you're telling me? Ay, ay, ay. How do we do that? All frames, because we would need to move this to another frame, I think. That's not particularly great. I mean, I do have the original. Oh, okay, I see. Let me do some research real quick. Sprite sheet to frames. To import a sprite sheet, use that option. Okay, so we're going to just export this real quick. You know what? We don't need to do that because I think we can import this way. Select file, Charlie, by rows. The width of these is 32. The height of them is 64. Okay. Okay. So that got us what we want. So now we need to export all those. Yeah, okay. So what we're going to do is, I think we'll create a new folder inside of here. Charlie, PNG, save, resize. So we're going to resize these to 200. Oh no, because this should already be at its default size. Export the animation. We may need a... No, thank you. Export as. So we may need to put a dash in front of it. Yeah, okay. Agree. So let's go to our project. Playdate package resolved. Source images Charlie. Charlie 1, 2, 3, 4, 5, 6. Okay, great. So then we need to look at stuff in the graphics section. Bitmap tables. Okay. Load bitmap table. So it looks like it's the same thing. So let's make some modifications then. So we're gonna go back to our images here. So what is the return type of this? It is an LCD bitmap table load table const char start path and then a Playdate API reference. Okay. Going to copy the prototype. Do that. Right. So const char error is null. And then we just LCD bitmap table. Table is something, and then we're just going to return the table. Now, what is the method we need to call? Load bitmap table from PD graphics. Load bitmap table, and then we just pass in the path and error. Yep. So path and a reference to error, and then I think that's all we need. Cool. Okay. So we have that set up. So we're going to need to change this to a bitmap table to be the sprite table. So let's go back, and we're going to change this to table sprite table. Now the question is, what can we do with a bitmap table? Checking the time. Okay, we're okay there so far. Sprites. Do we have anything with a bitmap table? So far, I am not seeing anything. Maybe we need to get a specific one from a table. I imagine that's how we need to do that. Load into bitmap, tile bitmap, rotate a bitmap, get bitmap mask, turns the index, LCD bitmap. Oh, okay, okay. So we'll test that, like so. So images, Charlie. Oh, well, how do we do the load? Let's go back to the information about the bitmap tables real quick. Get table bitmap. Okay. From file at path. Okay. So we need to change this to images. Charlie, I think. So then we're going to say LCD. Yeah, no, we're gonna want this to just be a regular thing again. LCD bitmap table. Table is load table. Sprite sheet. And then PD. We're no longer going to need that, I think. So if LCD bitmap, I don't know, if table is null, then we want to PD system error missing the table. And then return 0. I just want to see if that even... Did you mean LCD bitmap table? Did I make a boo-boo when I... Oh. Okay. Missing the table. Okay, I had a feeling it was going to be that way. So let's try that again. Missing the table. That's not great. That is not great at all. At path. If there is no file at path, the function returns null. Returns file at path. Naming convention to the image table file. Oh. Oh. So you're telling me we didn't need to split this? Did we really just need to say table 3264? Was that it? Uh-oh. Is this what we have to deal with? Okay. PC sprite, non-null value map argument. Okay, so that means we didn't reach this breakpoint. Or we didn't reach that point. Okay. So why did we need to do this? What did we... Okay, fine. So then can we set these dev forms, saving me yet again. So then we just want to get this, right? So then we can set, oh, this is still running. Let's take care of that. So then we can say that the sprite image then is table, or no, we want PD graphics, what is it? Get table bitmap? And then we pass in our table at IDX 0. Do we get the single bird? Hey, there we go. Alrighty. One frame. One frame. Okay. Okay. This is good. This is good. This is very good. So then let's adjust a couple things around. So we'll store that table somewhere. Bitmap table, right? So we'll take care of that. Right? Yes. Okay. And then we will also keep track of the frame that we're on. As well. So then once we get down here, because this is where our final updates occur, frame plus equals 1, or I don't know if that works. I don't trust that. If the frame is greater than 5, because that's how many we have. Or we have 6 frames total, but the index is up because of the 0 indexing. I think that does it. No. Oh, because we also need to move this out. Look at her go! Look at her go! She's so fast! Sonic! Brilliant. Absolutely brilliant. Wow. She really speeding. So we're gonna need to change the frequency in which we update that. So I guess we'll say bool frame updated is false. So then we can change some of this logic around. If frame updated is true, updated is false, else, kind of hacky, but you know, this will work. And then I think this saves us the trouble. There we go. Now she's moving at a more reasonable pace. That's awesome. Okay. Let's clean up some of this code a little bit, and then we should be a-okay. So I think what we'll do is, first off, let's set the widths and heights for these things. So we'll go here, define sprite height, or I guess we'll do Charlie height, 264. Define Charlie width to be 32. Actually, let's move that up a line, just so it's a little bit cleaner. And then we can change this to be Charlie width, Charlie height, so that way it doesn't look so weird. And I think we could probably move this out into its own thing as well, so let's try writing a thing for that. So we don't have a new header file for that, so let's take care of that real quick. We will call this, oh, you know what? I don't think we could do this in Charlotte because we're working with the Playdate API for that. Oh, duh, we have this right here. So we'll do an LCD sprite image sprite. And I'm just going to move this here so I can look back at the source code we have currently. Right, because we need to create a new sprite. Image sprite. And then I think we can... I think this is where we would also need to include vector.h vec2i size, followed by, do we want to allow the flipping here? I think we're fine there, right? Because we have sprite image. Oh, we should also probably get the image as well. LCD bitmap image. Okay, that's fine. Actually, why did I? Okay, so let's go back here to images.c. Right, okay. Oh, we also need to pass in the PD, just so that we have that moved out. So we'll copy this code, like so, size.x, followed by size.y, sprite image, k-bitmap unflipped sprite. And then we just need to return sprite. Like that. So then I think we can just call sprite equals imaged sprite. Oh, we need to go back to the header file to also allow this. Yeah, we should probably make that a bit more consistent. It's fine. So we'll just imaged sprite. And then we'll also do that too. vec2i sprite size is Charlie width, Charlie height. So we have our PD, and then we have our size, so sprite size. And then our image sprite is going to be sprite image. Let's see if this does the trick. Build failed. Oh no, because unknown type name vec2i. Even though we're including vector.h. Oh, we're not including it in here. Okay. Boop. Sprite image undeclared. First use in this function. Oh? But you're right here. Oh, it's in our implementation of this method. There we go. Alright, that's awesome. Okay, that's good. That is very good. So we managed to move that out. So we can clean up that piece of code. We can also get rid of this comment, I think. Okay, that is looking very good. I think we can also just merge this back to the main code base since we don't need to worry about having to do other things. So let me just format all of my source files real quick. That took a while to run. Shocker. Okay. And then we will take care of that. Oh, it also formatted that one for me. Okay, that's fine. I don't think it'll be the end of the world there. Okay, so draw a sprite sheet to the screen. So then, I'm just gonna open this here. Clear, and then we're gonna do a get rebase tag I origin feet sprites. Git push force. Git push delete origin feet sprites. Doesn't make sense without any refs. Ugh. Oh, okay. Git branch tag d feet sprites. Oh, I think it's because we have origin here. That would be why. Delete doesn't make any sense without. That's what it was. Okay, excellent. We are making good progress here. So let's go back to the discovery tree. Wow, look at that. Let's go back to large, because this is probably going to be where the stream ends for today, but alrighty. We managed to more or less kind of set up the fundamentals for this, which that's exciting. I'm just going to make one more thing here. I'm going to extend that out all the way. Alright, because all that's left now is to draw the rest of the owl. But that is very good. We've made good progress today. So next week, we'll be doing that. Take it easy, everyone.